Hello. Am I audible now? Am I audible? Am I audible? Yes. Okay. Okay, cool. Uh, Give me a sec. Okay. Let me get started. Today we are gonna look into Numpy. Okay. So, uh, Numpy is basically a library uh, where it helps us in doing mathematical operations on vectors. So NumPy is library. It helps in mathematics. Oh, my screen is my screen visible? Okay. Now is it visible? It's visible for me from other device. Yeah. Okay. No issues. So I will not be able to see your chat. I will look into it every 5 minutes or so. So, yeah, it's a mathematical library. It helps us in doing mathematical operations on vectors and matrices, and it is very fast. Okay. So let's start by importing NumPy library first. So we are gonna write import NumPy as np. Import NumPy as np, and let's start by defining NumPy array. So I will write arr is equal to np dot array, and then here inside a list I can pass the numbers 1 2 3 4 5, and I can hit enter, and if you see, it's of type array, so it's different from list. So list, it's 1 2 3 4 5, and if you print list it will be something like this, but NumPy array is different from list. So NumPy array is different from list. Major difference is NumPy contains homogeneous data types when compared to list, which can contain heterogeneous data types. Okay. And in NumPy, operation happens element wise. Let me give you an example for you. So if I print list multiplied by 2, and if I print arr multiplied by 2, you can see the difference. Over here, this list have been extended itself by the same elements twice, whereas this NumPy array, each element got multiplied by 2. So it's a major difference. When you perform any operations like multiplication, addition, it happens element wise. Let's take a look at addition. So each and every element got added by 1. So this is how this this numpy array operations happens. It happens element wise. And numpy internally uses C arrays. Uses C arrays. Hence, it's faster when compared to list. So this is one of the major reason why most of machine learning libraries uses numpy. So you can just see the type of numpy array by writing type. You can see it's numpy n dimensional array. Any doubt so far? Guys, comment yes or no. Okay. C array. So C array in the sense C programming language array. So that's it. Uh, Prashant, anything else you wanted to look into some properties of C programming array? C programming array are nothing but they are homogeneous in nature, and C programming is fast when compared to other programming languages. So, okay. So now let's create a 2D array, 2D numpy array. Okay. So I will write arr2 and then mp dot array, and then here I can provide a 2D list 1 2 3 and then 4 5 6, and I can print arr2. Here it printed the 2D array. And you guys know Python range function, right? Similar to that, here we have a range function. So it's np dot a range, and then one second. Yeah, np dot a range, and here I can provide it number 5. So it's gonna give me numbers starting from uh, 0 till 4. So, and I can also give start and stop for it. So let's say I want it to start from 2 and end at 4, then I can provide it 2 comma 5. So it's gonna start at 2 and end at 5 minus 1, which is 4. So here you can see. And if you want to give it in steps, then you can provide it like this. So it starts from 1, then it increments each number by 2 till it reaches 9. So after reaching 9, it's gonna stop. So here you can see. So it's similar to range function. All the properties can be applied: the start, stop, and step. Any doubts? So, okay, C programming embedded in Python, we can use C features with Python, just like we do it for HTML and JavaScript. I'm not aware of HTML and JavaScript. Yes, we can use C features within Python by using NumPy. You are right, Print. Okay, now let's say you want to create uh, If you want to create evenly spaced numbers over an interval, what you will do is you will write something known as linspace, and then here you will provide start and then stop and then how many numbers you want. So here it start and then stop and number of elements in array. So these are the arguments for it, and then if you print this arr4, you are gonna get five evenly spaced numbers in between 0 to 100. So this is like a uniform distribution between uh, 0 to 100 of five numbers. Any doubts? Okay, so let's move on to next thing. So if you want to create an array of zeros, so if you need to create array of zeros, then you can write zero array, and then you can say np dot zeros, and then you can specify how many number of elements you need in that array. So it's gonna create us an numpy array with three zeros. Let's say you want to create a random number array which is having a range from 0 to 1, 0 included and 1 excluded. How you can do that is np dot random dot rand, and here you will specify the shape of the array. So I will come in a second what is shape of array, don't worry. So if you print, you're gonna get a whole uh, list of array elements. Okay, uh, let me say three. So you are gonna get an numpy array with three elements. Each of its values will be ranging from 0 to 1. Why do we use these arrays? Already has some arrays which requires less storage and make it efficient. And what is extra features apart from being fast? Apart from being fast, it has so many other features which we are gonna see today, which are not possible, which we cannot see in list, but we can easily see in numpy. I will come them in a bit. So yeah, now we are gonna look into something known as uh, properties of the numpy array. Yeah, so as you can see, this first numpy array is a 1D array, and second numpy array is of 2D array. How can we know the dimension of the array is? We can just type arr dot ndim, and then it's gonna say 1 because this is 1D array. And if it is a matrix, then we are gonna see it as 2 because it's a two-dimensional array. Now there is something known as shape of the array. Okay, so this shape of the array is nothing but number of rows and then number of columns in the array. So in first array, as you can see, there are only five numbers and then no other row is present. So we can see the shape by using dot shape operator. As you can see, there are five elements and then no other column or row are present. So it's gonna print 5 comma, and then if I write arr2 dot shape, then it's gonna print me 2 comma 3, meaning here we have two rows and then three columns. So this 1 comma 4 is one column, 2 comma 5 is another column, and 3 comma 6 is another column. This 1 2 3 is one row and 4 5 6 is another row. So that's why here we have 2 comma 3. And we can also get the data type of numpy array by using arr dot dtype. 0 array dot dtype, if we check, it's gonna be float. So yes, so that's all about properties. Let's see something about accessing elements. So yes, coming to this accessing elements, you can access elements similar to list. You can access elements by index, and here you have negative index is also allowed. Let's see the array once before trying out. Yeah, it's similar to list, and then even slicing rule applies. Rule also applies to numpy arrays. So yeah, arr dot one comma 4 I can print. Yeah, similarly all the accessing rules applies. One more thing which is interesting is known as masking of array. uh, okay, let's define a numpy array. Okay, so let's say 120 30 2 4 5 9. Okay, and if you want to filter, if you want to filter only elements greater than, let's say, 5, then you will write something like this: arr of arr greater than 5. So it filters out all the elements greater than 5, and it filters. One is not greater than 5, hence it didn't print it in the result. But 20 is greater than 5, it kept it in numpy array. 30 was greater than 5, it kept it in numpy array. 2 and 4 are not greater than 5, hence it dropped. 5 was not greater than 5, it's equal to 5, hence it dropped. 9 was greater than 5, it kept it. So this is how masking is done. Uh, any questions? Om Pranit Prashant. Okay. No comments in the sun. So I will assume no questions. Okay. Next, we have something known as operations on the array. The numpy array. Array. Okay. So operations on the numpy array. First, let's look at arithmetic operations. Okay. So let's first see. Okay, let's first define numpy array. Okay, and let's look at addition. Okay, you can do element wise addition uh, just by typing a plus b, and you are good to go. It subtracts, sorry, it adds both the corresponding elements and then prints you the result. So, 1 second, let me share my whole screen. Yes, is it visible? Why am I not able to write? Oh, I haven't connected. Okay. So here we have 1 comma 2 comma 3 comma 4 comma 5. Okay, and then we have 5 comma 6 comma 7 comma 8 comma 9. Let's say we have these two arrays. Okay, and then these two are numpy arrays. Then a plus b will result in, what is 1 plus 5? 6. And then 2 plus 6, it's 8, 10, 12, and then 14. So this 6 came from 1 plus 5, and then this 8 came from 2 plus 6. This 7 came from 7 plus, sorry, 3 plus 7, and then this 12 came from 4 plus 8, and then this 14 came from 5 plus 9. So this is how the operation works. So yeah, and similar to that, if you want to do element wise multiplication, then we will write a star b, and then element wise division we write as a divided by b. Pranit, you are asking, right, like why do we need numpy array only because it's faster? It's also because we have element wise operations in this. So and let's say if you want to compare, okay, function operations. So here we have two kind of operations. One is element wise comparison. So if you want to do element wise comparison, then you can write as a equal to b, then it's gonna say whether the corresponding elements were equal or not. And if you write as a greater than b, then it's gonna say you whether the corresponding elements were greater than or not. And if you write as a less than b, then it's gonna say whether the corresponding elements were less than or not. And similarly, you can apply greater than or equal to or less than or equal to. But if you want to compare the whole numpy array and say a boolean expression whether it's equal or not, then you write np dot array equal, and then you will pass the two numpy arrays, which is a comma b, and it's gonna return you a single value which says whether it's true or false. Yeah. Next, we have matrix multiplication. Yes. This is very important. So please pay attention. So I'm writing first array as mat1, and I'm gonna pass in a small array 2 and 1, and then mat2 dot array, and here we have 2 comma 4. So if we do np dot mat mul for matrix multiplication, and if we pass mat1 comma mat2, then we are gonna get 4 and 8. How it's, let's see. Yeah, so here we have mat1, which is nothing but 1, it's 2 and 1, and we have mat2, which is 2 comma 4. So if we multiply 2 1 with 2 comma 4, so its dimension is 2 cross 1, and it's 1 cross 2. So the resultant matrix should be 2 cross 2. So let's see. So it's first row into first column, two twos are 4, and then first row into second column, two fours are 8, then second row, first column, 2 1 is 2, then second row, second column, 4 1 is 4. So it should be 4 8 2 4. Let's see what we got. We got 4 8 2 4. So it's correct. So one more way of doing matrix multiplication is using at symbol. So we can write mat1 at the rate mat2, and we will get the uh, matrix multiplication. And one more thing which we can do is, if we need to find the dot product, then we can use this. But there is a catch. If matrices are 2D, then it performs the matrix multiplication. So yeah, np dot, and then here you can type mat1 and mat2, and it performs the matrix multiplication. What if both are one dimensional array? So Here we can write np dot array and 1 comma 2 comma 3 comma 4, and then b as np dot array, and then here I can write 5 comma 6 comma 7 comma 8. Okay, and then if I print np dot a comma b, then it's 70. So how this is, so first array you saw I had 1 comma 2 comma 3 comma 4. Okay, and second array I had 5 comma 6 comma 7 comma 8. So what dot product basically does is, what this does is it performs element wise multiplication and it adds them. So it does 1 into 5 plus 2 into 6 plus 3 into 7 plus 4 into 8. So can anybody let me know what's the result of this in comment? So you have 5 minutes. Is it done? Yeah, you are correct. It's 70. So it is 70. So this is what dot product means. It's element wise multiplication and then adding all those terms. Yes. So that was about dot product. Next, we will look into some concept known as axis. So, so this is very important concept. So please pay attention. So most of the times in machine learning, we deal with matrices. So let's say we have a matrix 2 cross 3 as shown here, and here this horizontal part, this is known as axis 0. sorry, not horizontal, this is vertical. So also known as vertical axis. This is also row wise. Why? Because it takes elements uh, of different rows and combines it to form a single element. So if I collapse, then one is gonna come on 4, and 2 is gonna come on 5, and 3 is gonna come on 6. So in that way, it will collapse to form a single row. Hence, it is also known as row wise. And if we take a look at horizontal axis, then it is known as axis 1. It is also known as horizontal axis. It is column wise. So why? Because if I'm collapsing, then 1 is gonna come on 2, and 2 is gonna come on 3, and 4 is gonna come on 5, and 5 is gonna come on 6. So in that way, if collapse happens, then it results in a single column. So that is why we call it as column wise. Any doubts? Okay. Let me also show you how this collapse will happen. So, so if collapse happens, then it will happen like this, and then it will result in a single row. Hence, it is known as axis is equal to 0. This is row wise collapse, meaning all the rows are gonna fall on top of each other. And then if I have similar thing, 1, 2, 3, 4, 5, 6, and if the collapse happens along this direction, then it's gonna result in single column. So this is axis is equal to 1, and it is column wise collapse. What do we mean by this? We are gonna look now. So yes, let's start by defining an array. So and okay, before that, now the topic is universal functions. Yes. So if we want to calculate sum of all the elements, so let me print this. Yeah. If you want to calculate sum of all the elements, then we are gonna write np dot sum, and then we are pass array of 2. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 results in 21. But what if we want to find the sum column wise? Then we are gonna write np dot sum and then arr2 and then axis is equal to 1. So, so if we want to find column wise sum, so what's the total number of uh, what is the total sum along the horizontal axis? Then we are gonna pass axis is equal to 1, as you saw it over here. It did column wise collapse and then got the sum. 1 plus 2 plus 3 is 6 and then 4 plus 5 plus 6 is 15. Any doubts? Okay. And then if I write, if I need to find the sum row wise, sum, then I can write np dot sum array2 comma axis is equal to 0. So here you can see I am getting row wise sum. 1 plus 4 is 5, 2 plus 5 is 7, and then 3 plus 6 is 9. Similarly, we have np dot mean can pass array of 2. It finds the mean of the array, and we have np dot min to find the minimum array. In the array, and then np dot max to find maximum element in the array, and for all the above functions we can use axis. So let's try it out. If you want to find mean across all the columns, so then we will type and axis is equal to 1. So mean across all the columns. So here we can see that mean is 2 and 5. So we got 2 and 5, and np dot minimum element if we want to find across, this time let's say all the rows, then this will be nothing but the first row of the array 1 2 3. Yeah, and then we have something known as logical operators. Yeah, so let's say we have two arrays. Oh, okay, before moving to that, did you guys got this axis part clear? It's very important going forward in ML algorithm. We will be using it at many places. So if you guys are not clear, I can explain you once more. Okay, no reply in the sense. Yeah, no question. Okay. Next we have logical operators. So first one is any. So okay, first let's define two numpy arrays. Okay, any doubt? Understood, but possible do once more. Okay, sure, no problem. So, yes, here coming to this axis part, here we have a two-dimensional array, namely it's 1, 2, 3, 4, 5, and then 6. So, if we want to find the sum of these two elements, 1, 4, 2, 5, 3, and 6. So at that time, we will use axis is equal to 0. This is a vertical axis. Is it performs the row-wise operations and it collapses everything into a single row. So that is what axis 0 means. But what if we want to perform the same sum across the horizontal axis? So what if we want to find the sum of 1, 2, and 3, and then 4, 5, and 6? So at that time we will use axis is equal to 1, which is a horizontal axis, and it performs the column wise operations. So similarly, we will use these functions over here. So np.sum axis is equal to 1 results in getting sum of all the elements in each row and then presents it in a single column. It is a column wise operation. And then similarly, if I do axis is equal to 0, then it's gonna calculate sum of 1, 4, 2, 5, and then 3, 6. So it results in 5, 7, and then 9. So did you guys understood? Okay. Yeah. Next we have something known as logical operators. So let's start by defining an array. So it's 1, 2, 3, 4. Okay, let's do something else. 20 and then 40. Okay, and then array 2, array, and then I will write 1, comma 2, comma 3, comma 4. Okay, now we have any operator. So if we want to find if there exists a single element. Okay, let's see the result, then I will explain you. Any, and then ARR1, and then ARR2. Oh, why didn't I remember this? Oh, what is this? Oh, sorry. Yeah, this checks if I want to find if there exists a single element which single element in array 1 which is less than element in array 2. So as you can see, it cannot find any element in array 1 which is less than element in array 2. Let's modify it a bit, and let's say I'm making first element as 0. So it found an element in array 1 which is less than element in array 2. So it printed true. So uh, it compared each and every element and it tried to find the uh, correct uh, it tried to find if there exists any element in array 1 which is less than any element in array 2. So this is any operator. Similar to that we have all operator. So if we want to check if all elements in array 1 is greater than elements in array 2, then we are gonna write np dot all arr1 comma ar sorry arr1 comma arr2. So as you can see it printed false because there exists an element in array 1 which is not greater than the corresponding element in array 2. So that's was about logical operations. Now let's look something about array manipulation. Yeah. So first thing is reshaping. So let's define an array. Let's define a 3D array. Okay. Let's check its shape. Oh, to add one more set of bracket. Yes. So as you can see, it's a 3D array. So inside it we have one row. Inside it we have two separate rows, and then we have two columns in each row. So now let's reshape this into 2 cross 2 matrix. Okay. So what we can use is arr3d dot reshape and then 2 comma 2. So as you can see it converted into a matrix of shape 2 cross 2. And here we can also use negative indices, also use negative indices if we are not sure of the shape of dimension. So shape of only one dimension. Okay. So I will write arr3d dot reshape and then 2 comma minus 1. If I write like this, it converted it into a, matrix of two rows, and then I let the numpy array decide on number of columns. So that's why I passed minus 1. So if I write arr dot reshape minus 1 and then 2, it converted. So it decided number of rows it need to make, and then number of columns. So based on the number of columns, it decided the number of rows. So any doubts? Okay. So now let's say I want to flatten this list. So how we can do that is ARR 3D dot flatten, and then this list will be converted into a single dimension. I can also use other functions known as ravel to flatten, and if I want to transpose the list, so let's first reshape it. Yes, and then let's print this reshaped list. Okay, and I can transpose it by using dot t. So I will explain you what transpose operation is. So let's say we have matrix 1, 2, 3, 4. Okay. So if I apply transpose operation on this, then the rows will become columns and then columns will become rows. So it will be 1, 3, and then 2, 4. So this is what transpose operation is. Operation. Rows and columns are interchanged. Yeah. Next, we have something known as sorting. So let's define an Numpy array, and then let's keep like this. And if I want to sort, then I can just write np dot array dot sort, and then if I print now, it will be sorted. So this is how sorting operation looks. Yeah, that's it I have for today. There are few concepts like broadcasting, H stack, V stack, which I will cover in next session. It will be too much. By the time, please practice this uh, axis part, because it will be very useful in understanding H stack and V stack, which I will carry out in next session. So yeah, that's it from my end. Uh, any questions? Yeah, guys, please do practice. Without practice, it's nothing. It's just like watching a movie and going. Uh, that's it. Yeah, thank you. I hope you enjoyed the session. Any doubts? Okay, thank you.